Hello, La Joya ISD. I'm Nidia Ortiz, Executive Director of School Leadership for Network 3. Explicit instruction is what brings learning to life in our classrooms. It is how teachers clearly communicate what students are learning, why it matters, and how to be successful. That clarity begins in PLCs, where lessons are intentionally designed, thinking is planned, and instructional moves are aligned. When that planning transfers into the classroom, explicit instruction becomes focused, consistent, and meaningful for every student. Professional learning communities are a critical driver of instructional quality and student success. The following video highlights how intentional PLC planning, grounded in high-quality instructional materials and our district lesson structure, translates into effective classroom instruction.
Guys, make sure that you go into your books. We usually go to our books all the time and we write our notes, and remember that your book is your resource. It's what we're gonna go back to whenever we need to check. Today we're focusing on identifying the constant ratio and the y-intercept on geometric sequences, and we're gonna look at different scenarios. We're gonna look at different representations. So right now, we're going to highlight the vocabulary word geometric sequence. So a geometric sequence is a sequence of values in which consecutive terms are separated by a common ratio. So there we have it. We have that word, common ratio, a constant ratio, not a common difference. So we have our constant ratio, our common ratio. Now, since you guys already sorted your sequences, I am more than sure that you saw this one. And if you look at it, we are used to seeing our sequences in that format. You have your first term. We already know that this is my first term in the sequence from our prior knowledge. This is your first term. This is your second term. This is your third. And this is your fourth, etc., etc., etc. Today, we are actually going to transfer that sequence to a table. And so I want everybody to look at number 1. Great instruction doesn't happen by chance. It's intentionally designed. As a math teacher, I want every student to feel confident, supported, and capable of mastering challenging content. In my classroom, I make sure students understand what they are learning, why it matters in the real world, and what success looks like for them. That clarity begins in PLC and comes to life through explicit instruction.
During explicit instruction, the teacher makes the learning visible. The objective is clearly stated so students know what they are learning and why it matters. The teacher models the thinking step by step, naming each move and explaining the reasoning behind it. Purposeful examples, strategies, and scaffolds are used to guide understanding, while frequent checks for understanding allow the teacher to adjust instruction in real time. This intentional approach ensures students are supported, engaged, and confident as they learn.
We are going to be focusing on different representations today, and we're going to be looking for that common ratio. That's the first thing we're gonna do. We're gonna check our common ratio. I am on page 554. So everybody should be on page 554. Everybody should be looking at number 1, and everybody should be looking at the way I do it. So I wanna make sure you all look and you focus on how I check that common ratio. We've discussed it before. We've looked at arithmetic sequences, and to find the common difference, can anybody share with me, how did we find that common difference on arithmetic sequence? Subtract. Yes, we subtract the second from the first one. Can somebody else in the class tell me about the second and the first one? What is Abraham referring to when he says the second and the first one? The terms, the second term and the first term. That's what we would do with an arithmetic sequence. We would subtract them. So now, to look for a constant ratio in a geometric sequence, we're gonna go to the second term and the first term, and we are going to divide them.
During PLC, the teacher will intentionally plan opportunities to model think-aloud problem solving so students will clearly see the thinking behind the skill. In the classroom, this will show up through explicit instruction, where the teacher will verbalize each step, decision, and strategy while solving the problem. This intentional modeling will ensure students understand not just the answer, but the process needed to independently apply the skill.
So let's take a look. If I look at table A, I'm going to go to my second term and my first term, and I'm going to go ahead and divide them. -6 divided by -2. What do I get, guys? 3. Now I'm going to check if it's constant, which means I'm going to check and see if it's constant throughout my table. So I'm going to check now my third and my second. And I'm going to divide. -18 divided by -6. What do I get? 3. Good. Is it looking constant? Yes, it is. One more. Look at the last two. -54, -18. If I divide them, guys, what do I get? +3. Is it a constant ratio? Now remember that we saw the sequence in this format, but we can also see our sequence in this format. I'm already going to tell you that in EOC, we usually see it in this format. You know, we got our first term, we got our second term, third, fourth, and we see it like that. But looking at a table, we all know that tables are made up of ordered pairs. And so from this table, I graph it. My first order pair, 1, -2. So I graph it. 2, -6. Check out how we graph. Check out how this graph relates to this table. And look at your graph, because in a little bit, you guys are going to discuss with your partners, what do you see about the table, about the graph? And I want you to look at the last one, representation of an equation. Look at that equation. Does anybody notice anything about that common ratio? Do you see it anywhere on that equation? Where do you see it? The 3. So this is my common ratio, my constant ratio. Now, remember that today we have two things that we have to do. We have to look for the constant ratio. We have to look for the y-intercept. So I already showed you how to find that constant ratio. So now I want us to do table B. We're going to look at table B. We're going to do it together, and you're going to do the last table by yourselves. So you ready? Here we go. Table B. The constant ratio. How do I find the constant ratio? Somebody in the class, really quickly, what do you think? Oscar, you divided. Who do I divide? The 90 and the 45. Everybody, please divide it. 90 divided by 45, what do we get? 2. The constant ratio is 2. And just because that looks super easy, let's do it again, just to verify that it is a constant ratio. Let's do the next two terms. 180 divided by 90. 2. Is it a constant ratio? It's a common ratio. Now I want you guys to try it. I want you to go to table C and check out table C. How are we going to get the constant ratio?
Intentional PLC planning leads to explicit instruction that is focused, consistent, and meaningful. When teachers plan together with purpose, instruction is clear, expectations are high, and students are supported in every classroom.
Because our PLC work is intentional and aligned, my instruction is focused, consistent, and meaningful. Students know what to expect. I know exactly what to teach, and together we create a classroom where learning feels natural for everyone. This is how our PLC planning transfers directly into explicit instruction, and how I ensure every student receives high-quality instruction every day.